Ladies and gentlemen, our program will now begin. Please welcome the CEO of the Churchill Club, Karen Tucker.
Thank you very much. Thank you so much. It's great to be here with you tonight. We appreciate you coming out for this. The discussion is called Urban Air Taxis, Preparing for Liftoff. We have a diverse and distinguished group of leaders in the room to address the topic, not just on stage, but also in the audience. On stage, we have Joe Ben from Joby Aviation, Joe Ben Bavert, Raquel Gervin from the FAA, Federal Aviation Administration, Nikhil Goel from Uber, Zach Levering from AQ, Airbus, and Vijay Reddy from Intel Capital. Here to guide them in conversation is Matthew Quinlan of Accenture. Matthew is a subject matter expert himself, and we have asked him to also weigh in on the discussion, so we hope that he does. Special thanks to Accenture and Matthew for their support and encouragement in developing this program, and also to Vijay Reddy, who was very helpful in helping us to further develop the content. As always, it takes a knowledgeable and giving group to provide these programs that we do for you, so we appreciate it very much. Thank you. At Churchill Club, our passion is to inspire and fortify people who are working toward innovation, economic growth, and social good to help them be better innovators, leaders, collaborators, and citizens. It's part of our work as one of the premier independent thought leadership forums in the world. And in the conversations that we convene, we always ask for what's new, next, not widely known, to surface new insights and inspiration that we hope will result in new and better opportunities to create and meet the future together. Those of you who have joined us in the past know that we also ask our speakers not to pitch or promote or position, and everybody's agreed to that, so we look forward to their insights as thought leaders. After the onstage conversation, Matthew will open up to a full room discussion. Hope that you'll raise your hand and help to have the most balanced discussion possible in the room tonight. So with that, let's welcome our panel. Thank you.
Microphone, we on? Great. Karen, thank you. And thanks to the Churchill Club team for another great event. I know this event in particular has been much in demand for some time. We've got a great panel, and if you've been following, it's been expanding over the last week, so we're very privileged to have views from the investment community, from entrepreneurs, from aerospace, from regulation and government. So it's a great diverse perspective that we'll hear from tonight. So thank you all for making it. I wanted to acknowledge up front that urban air taxis is one of those areas where popular culture has kind of given us a head start and probably created some baggage for us. The first film I ever snuck into underage was Blade Runner back in 1982, and it, like many flying cars, and I'll use that term only once, really captures the imagination. And it always sets it against a very futuristic backdrop. And I think what you'll hear from tonight is that this is something that's becoming very real. The opportunity, the technology, the investment, the community and regulation is moving this along at quite a pace. It seems very fitting that California should be the home of this conversation, which is maybe the spiritual home of bad traffic and congestion. A lot of the innovation, I think, and inspiration in the industry is inspired by people sitting in traffic for too long and coming up with ideas for how to change that. Personal transport really over the last 100 years has been a 2D problem. And I think we're seeing increasingly in recent years that even over short distances that the third dimension is becoming something to explore, whether it's going back underground or taken to the air. And our experts here are really pushing that aerial initiative. But going up holds the promise of reducing emissions, reclaiming a lot of the time we lose on the roads, and really shifting how we live, where we live, but not without addressing the issues of safety, noise, infrastructure, regulation. And that's really our topic for today. I wanted to start with the panel just briefly introducing yourselves, a little bit about yourself and the role you and your organization play in this, and also helping us level set a little bit about where do you think we are at the moment in this space. Raquel, do you want to go first?
Sure. Good evening, everyone. My name is Raquel Gervin, and I am a program manager for the FAA's Unmanned Aircraft Systems Integration Pilot Program, UASIPP. With the FAA, you got to use acronyms. So it's actually quite fitting, and there's a lot of sort of natural transition or relationship between what we're doing with the UAS Integration Pilot Program and the urban air mobility, urban air taxi world. Prior to that, I worked on policy issues at headquarters, but actually right now I live in LA, and the urban air taxi sounds very exciting for me because I live in Pasadena and I drive to El Segundo, California every day.
Yes. Nikhil.
Good evening, everyone. Super excited to be here. Thanks for the intro. Excited to be here with some old friends and some new ones as well. So my name is Nikhil Goyal, head of product for Elevate at Uber. Elevate is our urban aviation initiative. So we founded Elevate about 2 years ago with the focus of taking an open ecosystem approach to partner with companies across the ecosystem. That's OEMs making eVTOL aircraft, that's real estate developers, government partners, investors, et cetera, all with ultimately the goal of how can we help our 75 million riders around the world push a button and get a flight. So excited to chat about that today.
My name is Vijay Reddy. I'm with Intel Capital. Intel Capital is the venture arm of Intel Corporation. We invest between 400 to 500 million a year. My particular focus has been on AI and autonomous systems, invested in LiDAR companies and computer vision stacks and silicon and aviation companies as well. And I think my personal passion in this space has been around, I spent a decade in LA. The 101 was crazy. I came to Bay Area, 101 is still crazy. And no, it's yeah, anything we could do to solve this problem is a great thing in my opinion.
Hi, Zach Lovering. I'm coming from AQ'd by Airbus. Until very recently, I was heading up the Vahana program there, which is one of Airbus's first electric vertical takeoff aircraft programs. Been running that for about 2.5 years. Just recently got pulled up into Airbus's newly formed UAM division that was launched in June of this year. So I'll be heading up systems integration for that division. I think one of the big lessons we've learned is that the space is it's growing rapidly. There are a lot of moving pieces. At first, it seems like the vehicles are going to be the hard part, but then you find out all the other ones that are really hard, like ATM and infrastructure. So Airbus is really excited now to have kind of our hands wrapped around the whole thing and be able to kind of really push this forward from a perspective of a company that's been certifying safe aircraft for 5 decades now. So I think it's a really exciting space for us to be in.
Thanks. Joe Ben?
Hi, I'm Joe Ben from Joby Aviation. I have been dreaming about this all my life, and it's incredibly exciting for this day to be coming to fruition, where we get to take into the air on a daily basis and have air travel be part of our everyday lives. It took more than a decade of me going around talking with everybody thinking I was a total crazy lunatic before there started to be some people who believed that this was actually something that could close, that with electric propulsion you could fundamentally rethink aircraft and rethink the safety of aircraft, the acoustic profile of aircraft, and the economics of aircraft, to the point where we could save 1 billion people an hour a day. And that's what's so profoundly exciting about this. It allows us to completely rethink our civilizations, think about where we live, where we work, where we can go on a daily basis. And it changes real estate, it changes the fabric of our everyday lives. What if all the streets, what if all the pavement outside got turned into parks? How would living in cities be different? And so this is really exciting, and I'm thrilled that all of you guys are here tonight to talk to us about it.
Great, thank you. Vijay, I thought I'd start with you and try and get a sense of what's the problem we're solving? It sounds like congestion is kind of the primary driver for this. But really, who's it for? Who's the first adopter, and who's the mainstream for this kind of service?
Yeah, I think it's a lot of it has got to do with the congestion problem, right? And we'll start with the major cities which are clogged up. I think LA, London, Singapore, Dubai, and other places. And I think it's for everyday user, right? I think you'll start off at a higher price, but as Nikhil can talk to it a little bit later, the price is close to going to be like an Uber Black price to start with, and then it's going to go down the curve. So it's for everyday users. I think there's two ways to look at it. One is urban mobility, and the other is outside of in suburban places, right? I think on the urban side, the problem is real. It took me 2 hours to get here. Mm-hmm. I could make it 15 minutes, right, if I had to. So I think it's for every day. It's $20 to go from San Jose to San Francisco, maybe $50, but it's still worth it.
Yeah, and we'll get into, I think, the economics of it and how that really works. Joban, I wanted to get a sense from you of, you've been in this space a long time. I think you coined eVTOL as an acronym. What's changed? Why now? Why is it really coming to fruition now?
Yeah, so I think there's a bunch of factors that have come together. The first was, I was talking about electric, that allows us to fundamentally rethink aircraft design and allows us to make aircraft that are fundamentally, incredibly quieter, on the order of 100 to 1,000 times quieter than existing aircraft. And that allows you to rethink where you can fly these aircraft from and where you can fly them to. And the second factor, I think, is really similar to what's driven Uber's incredible success with, and all this shared autonomy. That's we're carrying around supercomputers in our pockets. And those supercomputers allow us to communicate with the cloud and book services and that sort of thing. So this connectivity, this notion of being connected, allows us to get much higher utilization of these aircraft by pooling people together, which in the early days when we're still flying with pilots will be incredibly important. And then the autonomy piece, where the sensors and the computing power to have these aircraft fly without a pilot will really be the next stage in driving the economics, from the price of a taxi down to the price of owning and driving your own car, and then eventually even below that. And then finally, advanced manufacturing. So both from on the composite side, but also on the metal additive side. And there's just so many amazing new manufacturing technologies that allow us to make aircraft that were much more challenging and much more expensive to make in the past.
On that point, Zach, maybe you could talk to us a little bit about the key technologies involved here. What are the key hard problems in hardware, software, services that go into this, and where we stand today?
Sure. I think if you had asked me like every week of the past year, I would give you a different answer. We just keep solving problems. So I think in some ways that's encouraging. I think early on, one of the biggest challenges is going to be around batteries. The amount of energy you can cram into like a given volume or a pound of battery, if you will, is kind of one of the key design constraints. I think Joban and everyone else who's actually designed an aircraft, one of these electric aircraft, comes to the conclusion pretty quickly that you're designing the airplane around the battery pack. So I think that's a big driver of it, both on the aircraft design side and on the economic side. So batteries are still relatively expensive as compared to other fuel sources. So that's going to be one of the key drivers, getting the costs much lower. So that's kind of the vehicle side of things. As Joban alluded to, I think noise is going to be another big constraint. So really getting your tip speeds down and kind of playing with some other games to drive noise down overall for the entire noise profile for the vehicle. But outside of the aircraft, there's still a lot of questions around air traffic management, how these vehicles are going to integrate into the airspace, especially when you have mixes of now coming online drones, small drones that want to operate in cities, existing commercial jets and helicopters, and now you have a mix of some people focusing on autonomous aircraft, other ones focusing on still having pilots. So getting all that stuff to integrate safely into the airspace is another quite a large challenge. But one that we've been focused on quite a bit over the last few years. We have a project called Altascope that's been focused on that, and they just actually released their blueprint for UTM. So overall, I think we're starting to solve that problem. So if you ask me in one more week, I'll probably give you another different answer. Right. But yeah, I think those are kind of the big challenges right now.
And Raquel, the investment in battery in particular and the impact that has on noise, that's presumably a positive for you from the FAA's point of view?
So as we were talking earlier, I'm just thrilled, speaking from the FAA's perspective, to hear that noise is something that the industry is really paying attention to at this point, rather than letting it be an afterthought, because that is a critical aspect. So yeah, absolutely. The electrical aspect of the aircraft, the lower tip speeds, as was mentioned, I mean, those are things that are really important. And the standards are going to have to be developed for that, in terms of what is the standard that would be acceptable to citizens, and for us that's part of. So it's public acceptance is something that is going to be a critical aspect of this sort of innovative technology.
Yep. Nikhil, we touched on autonomous versus pilot.
Yep.
How do you think about how that plays out? Does this launch with pilot and move autonomous? How does that?
Yeah, so starting in reverse, look, I think ultimately the end goal is absolutely autonomous, right? I think autonomy offers a number of different benefits. One is economics. So obviously being able to not have the pilot costs and also have an additional seat to carry passengers, ton of economic value there. So that's one. The second is safety. And so from a safety perspective, as you look at all of the incidents across commercial aviation, GA aviation, a large percentage of it is due to human error. And so we are very bullish on autonomy, very excited about autonomy, but we don't think that's the way it's going to start. The way that we see it starting is thinking about how do we not make regulation a critical part, how do we not put regulation in a critical path? So the way we're thinking about this is let's start with human operators, pilots, with a mostly automated aircraft. So the aircraft, just like commercial aircraft today, has a high level of autonomy that's doing a lot of the functions, particularly with distributed electric propulsion, because these aircraft are very complex. They have a number of different rotors, and so it's impossible to fly them completely manually like a helicopter. And so a large portion of it will be automated, but there will be a human operator there for certain portions of the flight profile. And so we see it with human pilots at the outset. It's actually not that large of a cost, but over time what we'll do is we'll prove out the level of autonomy, and then we will get to the point where it's safe, it's proven, we've worked with the regulators, and it's socially acceptable. And when we get there, that's when we feel comfortable about making fully autonomous aircraft.
And as we get to autonomy, maybe Zach, this may be a question for you, is what's the difference between, I guess we have a more of a sense of self-driving cars and autonomous vehicles. What's the same, what's different when you start to take to the air?
Yeah, there's actually a number of differences. In some cases, it's a bit frustrating when there's the analogy drawn between the two, because they are in two completely different universes. If you think about the operational environment of a car, so you can just imagine yourself sitting in the car and replacing yourself with an autonomous system. Look out in front of you. You have dozens or even more hazards within meters of your car, within feet of your car, right? The curb itself is a hazard. You want to scrape your tires on there. The car in front of you is a hazard. Even the street signs and stuff they're giving you information are a hazard. So you have the density of hazards for ground operations is much, much higher than the air. For those of you that are pilots out there, if you've flown, you have your Garmin up there and it shows you all the other aircraft that are in your vicinity, and you look out your window and you know there's 3 of them there and they're right next to you and you can't see them, right? So this is the kind of massive difference in hazard density that there exists in the two spaces. So I think that's the first one. The second one is that because the airspace today has a certain structure, but it's still relatively open as compared to ground. So if you think about ground operations, you have streetlights and stop signs. You have other people that you can't communicate with directly. I mean, you can maybe yell at them or something like that, or use your horn. But with aircraft, you have radios and other things like this. So the way that you drive on the streets it's fundamentally constrained by the network of systems that are out there. Like I said, the street lights, other infrastructure. It's also constrained by the roads. You have to drive on the roads. And when you move to the air, all of a sudden you unlock, firstly, an entirely new dimension. You can go up, down, left, right, side to side, forward, back. You can You're not constrained to the 1D, effectively 1D or 2D if you want to call it, roads, right? Roads, you have to pretty much go on those things. Now you can go any direction you want, so it opens up tons of avoidance. And also you have existing infrastructure for aircraft to communicate, and those are expanding as we speak. But you do have systems like ADS-B, which do show you other aircraft that are in the air, and you don't have that kind of a thing for cars. So I think these are kind of some of the big differences in those things. From a practical perspective, when you're engineering an autonomous aircraft, the sensors are also vastly different. Cars care about seeing effectively hundreds of feet in front of them, so not very far. We care about seeing miles ahead of us, right? So you're really talking about, even from a sensor perspective, there are different kinds of sensors. So I think there's quite a large number of differences, but fortunately, all those things I mentioned actually make the problem in the air easier, not harder.
Jobin, I guess on the flip side of the there being more objects and things to deal with on the ground, you have fewer examples that you can learn from of what's going to happen in the air. How do you think about actually training the machine learning algorithms when there's maybe sparser data of what you're going to encounter?
Sure, yeah. So
sorry, that was for Jobin. Sorry.
Oh, sorry.
Yeah, so I think this, the notion of, Zach was talking about with perception is we're going to really need to push the envelope on the kinds of sensors that are available. Today, the radar and there's a huge amount of radar work that's being done for autonomous driving, huge amount of LiDAR work that's being done for autonomous driving, but many of Zach was talking about, many of those are looking at ranges of hundreds of meters or, at most maybe a kilometer. For us, being able to see further because we're moving faster, and the closing speeds, on the ground, you're probably at most going to have a closing speed of something around 100 meters a second, whereas in the air we may have closing speeds of several hundred meters a second. And so more range gives a lot of virtues. And so I think that like it's taken some time before there was a proliferation of sensors for ground autonomy that gets us to critical mass, having a few more years to really percolate this, the sensors is going to be really powerful. We're also getting a huge tailwind from the investments in ground autonomy on the compute side. So companies like Intel are creating just absolutely spectacular new compute chips that allow us to do machine learning that wasn't even fathomable 5 years ago, where you're getting teraflops of compute performance in very small pieces of silicon that are incredibly power efficient, and that allows us to make smaller, lighter, lower cost. And so there's this notion that Moore's law is tapering off, but at least from my perspective, having been tracking Moore's law and the incredible things we can do with compute over the last 3 or 4 decades, I mean, it's staggering to me how much progress we're making today on compute, and then that drives the ability to come up with machine learning algorithms that let us do magical things. And so that's what I'm, it's just so fundamentally exciting and makes me get up every morning and be like, wow, this world is incredible. We can do anything we can dream of. So I'm very excited.
Raquel, one of the things in ground transportation is just the number of miles that need to be driven and accredited to get to full autonomy and proven safety. How is that going to work in the air, and what role does the FAA and others play in ensuring the safety of these things?
Well, it's, every conversation with the FAA pretty much starts with safety. We certainly take pride in the gold standard in the world in terms of the safety of the airspace. And so for us, industry has to come to us with their safety case. We have a pretty flexible regulatory structure, and if you are ready to come work with us with your new concept and both in terms of the aircraft and the airspace that you want to operate in, we'll work with you, and we can, adapt the regulations that we have. But the bottom line is, you have to come to us with the safety case. You have to just show us. I mean, it's pretty basic, You're not going to fall from the sky. You're not going to run into other things. You're not going to kill people. I mean, it seems, that in the end is the fundamental behind it. And so there is going to, certainly the fact that you're carrying people is a critical part of what we are all about. And you have to show that you are going to be operating very safely. Again, we really do take pride in our in the safety of the national airspace, and that is absolutely going to continue. There, that's not going to change.
Yeah.
Can I make a comment on
Please.
safety? Yeah, so I think one of the things that we don't celebrate enough is what a spectacular achievement we've had in aviation safety. So over the last 100 years, we have created not only the safest mode of transport, but the fastest mode of transport and the lowest cost mode of transport, which is commercial air travel. So if you look on a per passenger mile basis, it's really, really spectacular. And on safety, it's not just a little bit safer, it's 4 orders of magnitude safer than driving. We lose 40,000 people on the roads every year in this country. Last year, we lost 0 people in the air. In fact, for the last 10 years, we lost 0 people. This year, I think we lost 1 person, right? So that is a really, really remarkable achievement. We fly about half as many miles per year, passenger miles per year, as we drive, and yet instead of 40,000 people dying a year, we have something like 0. And the FAA and industry have worked together for 100 years to make aviation safer every year, and it is just amazing. And so we're standing on the shoulders of giants, and it is such an exciting thing to be able to make this level of safety, this potential with safety, part of everybody's day-to-day lives. So I'm sorry I'm so passionate about it, but it's
That's great.
I love it.
It's really incredible.
One thing that's great is that the FAA obviously cares a lot about this, and at the same time, it's also really pushing the envelope on how to be innovative here. And we've seen that with the IPP, with the work Raquel and our peers are doing. This is the first time, not only myself, but anybody on my team, a lot of whom have spent decades in aviation, have seen the FAA this aggressive, this innovative, literally to the point of I'm getting phone calls and emails from the folks who work with the FAA saying, move faster. Hey, where's this deliverable? Where's this? Can we meet sooner? Can we meet today? And it's absolutely unprecedented. In fact, Dan Elwell was at our summit, I think earlier this year, and he said, never before have I seen kind of all of the regulatory forces that be line up in this way for what people want to do, for what innovators and entrepreneurs and inventors want to do. And so the work that you're doing now with package delivery and with public good and with AED delivery and a bunch of other applications all across the states is just really awesome, because you can test all of these pieces around autonomy, around aircraft safety out with burritos or with things that don't complain as much as people. And you can prove out all of these, all of the software applications, all the aircraft applications, and then all of that tech will be directly applicable to what we're talking about, urban air mobility.
Vijay, we talked there about the pace of how things are moving. I want to kind of get to the million-dollar question of when, and your sense, particularly as an investor, of when you think this materializes.
Yeah, I think when we started looking at this space a couple of years ago, maybe 5 or 6 years ago, it was like, let's talk about land mobility first, and then let's come to aviation after we solve that problem. But I think we're very pleasantly surprised at the pace of innovation, right? And partly because we talked about FAA and how that was our big if and when it happens. And so that became a less of a concern, just looking at how fast FAA moved, right? And so we have a beer challenge at Intel, where at least at some of the partners there, like, how soon will we expect aviation, and is it going to be faster than level 5, or is it going to be slower than level 5? And I think the odds are skewed right now.
What's your take on that?
I think we're going to see urban air mobility faster than a lot of the level 5 autonomy, at least like the way we know it, right? And so the batteries are getting there. But I think, as Jobin mentioned, we've invested tremendously in autonomous vehicles, right, on the ground, and billions of dollars. And the ecosystem has invested billions and billions of dollars to get there. So all of the technology, at least a lot of it, can be reused for aviation and to get to the full autonomy space, right? And I think the big question is user acceptance, I think, which is what we're kind of pausing on and just waiting to see how, once we get the flights in, how people are going to adopt. But pleasantly surprised. And we used to track maybe like 6 or 7 vehicles back in the day. Now there's probably like 120 vehicles in the last 2 years. And hundreds of millions of dollars have gone into space. So we're hopeful.
Can I tempt you to make a prediction and timing, or anyone on the panel to make a prediction?
So for us, we're targeting to have our UAM services launched in mid-2020s. So that's not, I mean, the vehicle is probably about 5% of the problem. So it's vehicle plus some infrastructure plus ATM. It's all those things.
Mm-hmm. And look, that certainly lines up with our experience as well. We've got a number of partners, both large companies who've been developing aircraft for decades and small companies that have new innovative concepts that people have never seen before. And all of them are very much on track for around the 2020 time period to have kind of a first demonstrator that they can actually fly and show to the public, show that these vehicles are safe, that they're real, that they're quiet. And frankly, they're flying today. Like, I have seen several models of these vehicles fly myself, full size, carrying a pilot or flying by themselves. So they exist today. And so by 2020, I think we'll certainly see numerous. And that means from that point forward, if not sooner, that's when the certification timeline will start. So call that 3 years. 2023 is when we fully expect we'll see vehicles real, not only real, but certified and available for commercial service. And so that very much lines up with what we've been saying.
Sorry, Joe Ben, what's your take on this?
So we're working through certification now. We have a fantastic partnership with the FAA, and we're making incredible progress. It will really depend on how long certification takes, but we're very optimistic and hope to have this launched very, very soon. So for us, it's painful for me to watch so much productivity globally being wasted with people sitting in traffic. And so every day longer that it takes us to get this to scale, it's not just the time that it takes us to launch it, but it's when can we actually have this making a really meaningful impact for millions and then eventually billions of people a day. And that is, that's the finish line that we're chasing after really aggressively.
So what was the year you predicted?
I think the year to 1 billion people an hour a day.
No certification, I think.
Certification, the timeline that we're working with the FAA on is the end of 2020, but that's a very ambitious timeline, and it will. We have a huge amount of work to do on very rigorous testing of every single component and the aircraft as a whole, and so we have an incredible team, and they're working day and night with a huge amount of dedication, and we'll bring this to market as soon as we possibly can.
Zach, it looked like you wanted to follow up.
Yeah, the only thing I wanted to add was, while eVTOLs are just about coming online, in fact, we already do in some places have these urban air mobility services. If you go to Newark, you can fly Blade. Again, you can use a web service or an app, and you can actually just order the helicopter to fly you from one part of the city to the other. In Sao Paulo, Brazil, and in Mexico City, Airbus has VUM, which is also offering the same kind of services. So while the electric piece is not there, which is really going to be the key element of getting the cost down, we are already seeing the beginnings of this happen right now.
Raquel, I had to come to you last on this one. What's your point of view?
So, from our perspective, we are ready, and the key for us is the collaboration that you all have been talking about, because this is one thing that the FAA has really learned, is that not only do you have to work with industry, but you also have to work with the state, local, tribal governments, because they all have a stake in this, and also internationally. We have to also work with our international colleagues. So in order for this to really be the global phenomenon that we're all hoping and that it becomes, there are a lot of steps, and it is very complex, and I can tell you, even from the UAS IPP perspective, it's amazing how much we're learning in the process of working very diligently on fairly low-scale sort of issues. I mean, issues come up, that's why we do this, right? And so there is a lot of learning, there is a lot of work to do, and we are kind of taking the position of we don't know everything, and we really need industry to kind of work with us and help us advance it. In terms of the air traffic or airspace, certainly one of the concerns, and I think it's a real win from our perspective, is we can't overwhelm the system, and so we're going to need ways for this large volume of aircraft to sort of integrate with the current aircraft that we have, and figuring out how we manage talking to each other without really overwhelming the system. Obviously, technology is going to be the answer to that, and so.
I want to switch gears. Thanks. I want to switch gears a little bit into the economics and the business side of things. And perhaps Nikhil, maybe we've heard Uber talk about getting to competitive with a variable cost of car ownership. Lilium last month was talking about Manhattan to JFK in 6 minutes for $36. These seem like extraordinary numbers from where we stand today. Can you kind of unpack a little bit how we get to that level of economics?
Yeah, so look, this is obviously something we spend a ton of time thinking about. Uber is ultimately about cities, making cities smarter, better, more efficient places to live. And I think that starts with kind of what JoBen was talking about earlier with cars, with car ownership. And really we see car ownership as kind of, before Elevate even existed, as the #1 thing to get rid of to help cities. And so that's where we get the bogey of the variable price of car ownership. If you can hit that, then it's literally cheaper to fly to work than it is to drive to work. And so when we first started this, it was literally the first question Travis Kalanick asked me. He said, look, is this going to be something that everybody can just take to work twice a day? Or is this only going to be a rich person's toy? Go figure that out first and then come back to me. And so that's exactly what we did. And we came to the conclusion that not only was it very feasible, but there were kind of multiple paths of getting there. And so the way that we look at it is, look, if you look at a helicopter, it's about $9 or so per passenger mile today, roughly, give or take. And so you're already starting from an advantage place, because these eVTOLs that we're talking about are far better machines than helicopters. They're far less complex. They're all electric, so electric powertrains are about 3 times more efficient. They've got a wing that gives you another 3 to 4x efficiency. So ultimately, you've got a vehicle that's 10 times more efficient. That boils down to chopping out about 1/3 of the cost, so call it $6 a mile. So that's like the first step. Second step is ride sharing. So this is what Uber and a bunch of other companies have pioneered over the last decade. Ride sharing does 2 things. One, it gets you really high utilization. So helicopters today are utilized about 200 to 300 hours a year. We're talking about vehicles that are utilized 2,000 plus hours a year. And then second, it gets you load factors. So we're looking at vehicles that are about 4 to 5 passengers in size. And so particularly with fixed routes, with fixed nodes, and with demand liquidity, if you take a look at a city like Manhattan, where we've got 3 million riders every single week, or you look around the world, we've got 75 million around the world every single month, and you're able to pool them into fixed routes over kind of discrete periods of time, you've got a really, really high probability, particularly making those routes in times dynamic, of filling up the vehicle every single time. So you get high utilization, high load factors. That chops off 2/3 of the costs. Now you're looking at about $1.60 per mile. And then the last piece, the kind of really long-term future stuff, 2 pieces. One is scale manufacturing. So again, looking at helicopters, they're pretty much hand-built today. And if you think about helicopters a little bit differently, looking at eVTOLs, what if you made them more like an automobile? And so the CapEx is now a lot lower. And then you add in the final piece we talked about earlier, which is autonomy. So you remove the pilot, you add in a 5th passenger seat, and now you've chopped off another 2/3 of the cost. And so that's how we get to about 46 cents a passenger mile. AAA puts the variable price of car ownership at 44. And so we see the progression as starting at an Uber Black-like service, going to an Uber X-like price with ride-sharing economics, and then ultimately getting to the point where you can fly to work instead of drive to work.
Zach, you talked earlier about battery as a constraint on the amount of weight you can carry, etc. Is there an upper limit on the number of passengers that you can cram into a vehicle?
Certainly is, from a design perspective. I think just if you look at the space right now, of where people are designing eVTOLs, you're seeing anywhere from like 2 to 5. That's for a reason. It's mostly because of the batteries. So given current battery technology and depending on the size constraints of the vehicle, for example, if you put a weight cap on the vehicle of 2 tons, which is what, for example, EASA is proposing in Europe, or if you put a size constraint in terms of wingspan that also caps how many people you can carry. But I think that's kind of where we're at today with batteries. If you can get batteries to be twice as good as they are today, then that frees up at least 1 more seat, maybe 2 seats, right? And it will get there eventually. It's just kind of been a slow march to getting there. Overall, batteries improved by roughly 8% per year. Obviously, that trend won't go on forever, but that's kind of the rate that we're seeing in terms of increase in performance of batteries. So we'll get to higher passenger counts in the future, but today you're kind of in that 2 to 4 passenger range.
Right. And Vijay, when you look at the economics of this, I guess there are some assumptions like utilization. Nikhil, you talked about the number of hours each vehicle is utilized. If you look at demand of commuter traffic, is that more peaky? Are you able to get that kind of utilization?
Yeah, I think this is probably a better question for Uber in the sense of it, but just looking at some of the math, even from our independent consultants or even the kind of math we did, right? In some locations, it makes a lot more sense. Especially, I mean, these are all the talked about locations. We talked about London, LA, and New York, and maybe not New York because of the weather constraints, but especially overseas too. I think the math checks out. But even if it's 2x or 3x, what would be the price you pay for getting there in 1/3 the time or 1/4 the time and having to skip traffic? I think there's a lot of margin there you can play out.
Yeah, I think the short answer on that is yes, for a couple of reasons. One is pricing. So obviously ride sharing also pioneered this, where you can price according to whatever you need to be able to generate the demand and make sure that aircraft's filled up every time and also utilized all the time. And the second piece that people don't think about too much is induced demand, meaning people are not going to act in the future as they do now. So even today with ride sharing, you see that where our usage patterns today don't look like the way that car usage patterns looked like a decade ago, because maybe somebody takes public transit into work, but then takes an Uber out to lunch, those sorts of things. And so the example I always like to use is, well, if you from right here could get to the beaches in Santa Cruz in 12 minutes, maybe you do that over your lunch break. Maybe you do it 5 times a week instead of once every 2 months. And so we've seen this with every single form of transportation, whether it be the automobile, whether it's with highways, whether it's with public transit. And you'll see that here too, where people ultimately in the long run will change the way they live and work. You don't necessarily, if you live right here in Union, or work right here in Union Square, San Francisco, you don't have to live on Market Street to have a 20-minute commute to work. You can go live in Santa Cruz, you can go live in Marin, you can go live wherever you want to live, pay half the rent, have twice the size of an apartment or a house, a backyard, a place for your kids. You can do all of those things, save a lot of money, and still get to work in 15 minutes. And so the world's going to look a lot different, and those demand peaks are certainly going to look a lot different.
Right. JoeBen, I know you've talked about the impact on cityscapes and real estate and things like that. Can you kind of give us a sense of what does the network look like around vertiports and the hubs and spokes? And
yeah, so I definitely I have a dream that we can make these quiet enough that every rooftop or at least every commercial rooftop can have a takeoff and landing location. My dream is that everybody can walk easily on both ends of the journey. And like if you look at European cities and the health benefits that people get by walking to and from the subway station is really profound. And humans are made to walk, and doing more walking on a daily basis is super valuable. And so, yeah, my dream is definitely point to point. In order to get there, it will change some of the ability to fill all the seats, and that will drive towards actually vehicles with smaller capacities, and then that necessitates air traffic control, computerized air traffic control systems. And so there's a progression here, and you see companies like Airbus that are going, looking definitely at the end state, or not the end state, but like a couple of steps down the road. And I think that it's going to be very exciting to watch this future evolve from, the launch in the early 2020s to this at a really ubiquitous scale over the course of the 2020s.
And how big a challenge is it, creating the network perhaps within the cities? Is it new buildings? Is it conversions and delivering huge power to the rooftops? Or?
Again, my view is more small takeoff and landing locations, and so it's, for us it's around 300 kilowatt charger at the moment, and so that's not a super high barrier to entry. You don't necessarily need to install a new substation in order to achieve that, and it's existing rooftops. It's not putting 50 vehicles on a rooftop, and so that doesn't put a huge weight load on the building, so you can use an existing building. It does require access, so there is some capital cost associated with getting rooftop access. Places like parking garages, which already have rooftop access, are ideal. And so I think a lot of, and especially as you move to autonomy and parking becomes less necessary, those top floors, which are the hardest to get to, are really low-hanging fruit. I think, and one of the beautiful things about a network, our ground-based roads and streets are, you add, one more mile of street, you get one more mile of street, but you add one more node to a 100 node network and you get 100 new routes, or 100, the network effects are really, really spectacular and really exciting. So there's a huge amount of it drives economic value, which is really incredible.
Right. The node scaling is really key. And what's also beautiful is you don't have to have, you look at the HS2 railroad in the UK, where they're building out a high-speed rail from Birmingham to Manchester, and you kind of have to finish the whole thing before it actually has any value. With this, you can just start with 2 nodes. You can start with a route, so call it San Francisco to San Jose, and already you're adding a ton of value. And those 2 nodes can hook into existing forms of transportation, whether it's public transit, whether it's automobiles, bikes, scooters, or walking. It can plug right in, and already you're serving a route that's got tens of thousands of people taking it every single day. And then you add a third and a fourth, and it scales by the node, not by the mile, to JoBen's point. And that's what makes this really efficient, because our view is cities are fundamentally running out of space. And that problem is only going to get worse because the cost of ground transportation is going down. With autonomy on the ground, which is certainly our goal and a lot of other people's goals, the cost of a ground mile is going to plummet precipitously. And just like we've seen with every form of cost reduction, demand will go through the roof. And so we actually believe that there's just simply not enough room on the ground for all the demand that'll be induced. And so you kind of have to go to a system that scales exponentially versus linearly.
Right. And Raquel, as we move that congested traffic up into the air, does it have an equivalent of roads and road rules? And do we kind of cram all that traffic into a certain route? Or?
I mean, I think initially that is probably what we're going to have to do. Obviously, again, figuring out how to integrate all of these different types of aircraft into the airspace is certainly a challenge. And today, let's say in the LA basin, there's a way that we could do that with, in terms of a demo, not to the scale that maybe Nikhil is talking about, but certainly to demonstrate that you can do it in some kind of a corridor is probably feasible.
Right.
But it will require a lot of automation, for sure, and it'll have to be integrated.
Right. We'll be moving to questions soon, so I just wanted to put the thought in your head that if you have a question, this is the time to think of it. One of the things I wanted to just touch on was public acceptance. And you see with self-driving cars and the rare incidents that happen, that the industry reels a little bit from that. How resilient do you think the industry will be to the first incident, God forbid that there is one? Joe Ben, do you want to take a cut?
So I think I think the question around noise is really the crucial piece, and we really need to be very vigilant as a community. It's really easy to make loud aircraft. We've proven that for a very long time. We've known how to make quiet aircraft for a very long time, and we've chosen not to because of consumer behavior. Everybody wants an aircraft that's a little bit faster or can fly a little bit further, and unfortunately that usually results in making them louder, not quieter. And so the unfortunate thing is that as a result, if consumers buy aircraft that are the very loudest that they can buy, that means there's fewer and fewer places to take off and land, and it becomes a less and less compelling mode of transport. And so it's incumbent upon us as manufacturers to make the quietest aircraft we can so that we have the most ubiquitous form of transport that's possible because we have access to takeoff and landing infrastructure everywhere. And so that's what I've been laser focused on for the last 10 years. And is just really looking at how do we architect these aircraft to be spectacularly quiet. So it's having our number one priority is safety. Our number two priority is the acoustics, and number three is on the economics. And we hold that to a very high standard in our organization. It's just acoustics are absolutely central to the equation in my mind.
Thanks. Zach, did you want to?
Yeah, I think besides noise, which is obviously one of the most important factors to these vehicles, there's also the acceptance of autonomy, and we're starting to see it play out with cars as well. There's a little bit of hesitation. I think one thing that I have to remind myself is, so I recently had a boy, he's 4 months old now, and I think that we're not building the vehicle for our generation, we're building it for the next generation. And just like there was a period of time when elevators had pilots in them and they would drive them up and down, and eventually those went to autonomy, and then people were scared and they accepted it. And now we're seeing autonomous trams in airports, we're seeing autonomous vans coming out. So more and more people are accepting autonomy, and I think it's really critical to think, what is that next generation? How are they gonna view the world, right? We're seeing, even my sister, who's 11 years younger than me, she doesn't have a car. She never really wanted to have a car, right? And Uber and Lyft, for example, have really changed people's relationship with cars to say, hey, I can use this as a service. I don't have to have this responsibility to own a car and all the hassles that come along with that. So I think we're seeing a huge shift in behaviors, and really that's what we should be focused on, is what does that generation want? And I think the big things that they're focused on are noise, and they're focused on the health of our environment, right? Having zero emissions at the source, overall zero emissions entirely if we can get there as a state or as a country. So I think that's really how I view the public acceptance piece.
Right.
If I could add to, of course, I'm very happy to hear about safety and the noise piece, but also I think security, well, that's one of the things that we've learned in the unmanned aircraft systems world, is that, security concerns are a really big deal, and, that's part of what, we're ready to go with the rule, and then we realize, oh my gosh, there are these security issues that we really need to address. So I think that's an important one, and, privacy is another one. And so I think there really is a lot of this public acceptance sort of issues, and that's why in the IPP we are working and asking the state and local and tribal governments to work with their communities to have these conversations about what do your communities care about, what do they like, why don't they like, because those are the kinds of things that we may not be thinking about, because we're so excited about things. And they could come back to bite us. So.
Yep.
Yeah, I think it ultimately boils down to us to four things: time, calm, joy, and money. Ultimately, if you can build a product and or a service that can deliver all four of those things to people, then you've got something that a lot of people will accept. Maybe not all at once, but a certain amount, And as more and more people start to see that value being delivered across cities, across their commute, across work and home, then you'll start to get acceptance at an exponential rate. And we've seen this with we've seen it with scooters, right? Scooters for a long time were this kind of like dorky thing that some people used. I don't know as a kid. But now all of a sudden people started to see the value and cities are covering them. And you've seen this over and over and over again with all sorts of trends in transportation. I think you'll see it with this too.
I think as a user as well, right? I'm not an aviation guy, but just as a passenger, in a car I'm used to driving, I grew up like driving cars, right? And suddenly if you take the driver out in an autonomous car, you kind of freak out a little bit. But in an airplane, I'm always sitting. I've never driven an airplane. I've never piloted one. So I'm used to like sitting, and it's already 90% autonomous anyway. So the fact that an airplane with a pilot in the first few years can carry me around is not going to freak me out as much as in the space as maybe in a car, right?
Great.
And, yeah.
Thank you. Thank you so much. So probably a good transition then to questions. There are mics in the audience, I think.
Are we ready for questions? My question, my name is Patrick Egan. I'm with SUAS News, and my background is really unmanned aircraft, and I've been doing the integration thing with the FAA for 13, 14 years. We're trying to integrate small aircraft into the NAS. And Jovan, you were talking about certification, and then you said, oh, 2020, we're going to certified aircraft. And there's many levels of certification. Maybe you could talk a little bit about what type of certification. Is it going to be experimental, light sport? Are you thinking like we're going to be ready to go for 135, 121?
Yeah, so we are working on setting up our operation and our aircraft as for 135 operation. That's what's required for commercial operations of small aircraft, and so that's what we're laser focused on. That is the timeline that we're working with the FAA on. It is again a very ambitious timeline, and so I'm not going to bet anyone or bet the company on it, but it's what we're driving hard towards.
Thanks. Next question.
Hi, my name is Frederick. I'm with Arizona State Government, and as you know, Arizona has been a big believer in autonomy and testing, and it's a great aerospace for testing, and I just wanted more to say I support all of your efforts. I hope I can connect with you afterwards, because I really see that this is the future for our planet, and I hope Arizona, among other states, can play a role to make that a reality.
Thanks.
Next question.
I don't have a question, but I just want to make some comments. I'm Kenny Vasai from NASA Ames. NASA was not mentioned in the discussion, but we're working closely with FAA to retire some of the risks. I call them technical vertical risks that you mentioned. How do you integrate these vehicles with national airspace at different altitude? And flying from SFO to San Jose, you have to go through, or flying from downtown San Francisco to San Jose, you have to go through SFO aerospace. So this is a system of systems challenge. In addition to vehicle design, airworthiness, acoustics, you have to integrate this at the national airspace and all the interfaces that you have to be aware of. And so we're very excited about the technologies, and we're working with FAA and the industry to retire a lot of those technical risks, and looking forward into having the capabilities 5 to 10 years from now, or maybe sooner, hopefully.
That's an excellent point. I'm remiss for not mentioning NASA earlier. NASA pioneered a concept called UTM, Unmanned Airspace Systems Traffic Management. It's an acronym instead of an acronym. But UTM, I think, is the foundation of what all of us are working on fundamentally, where a guy named Tom Prevost was one of the key leaders that he worked at NASA for 20 years. It's essentially a decentralized way to manage the airspace with different USSs, essentially different service suppliers across private companies, and do so in a decentralized way for these unmanned aircraft that we're talking about. And we're starting to see it in package delivery already across the IPP, and it will be absolutely fundamental for pretty much everything we talked about in terms of operating in dense urban environments, in terms of operating autonomously. So NASA's led the charge on that, and will continue to.
Yes, and I did want to add that, when I was talking about collaboration, absolutely collaborating with agencies like NASA.
Yeah, and just a shout out, they have a NASA Grand Challenge coming up, right?
Thanks. Next question.
Bert Wank with InfiniRail, a power systems startup. Since the Christmas coming, I do have a wish list question. Integrating safety and power is inherent. If you look at your near-term 5-year technology roadmap and your 15-year mass adoption roadmap, what is your wish list when it comes to power and safety?
We'd like to take that one. What's the wish list?
I'll just from a vehicle perspective, since you mentioned power, I mean, batteries are a huge source of concern for safety as well, right? So fortunately, there are a lot of new battery solutions coming out that do solve the problem. In fact, you can go on YouTube and actually find cases of like new battery formats where they literally have an active battery pack that's hooked up to like a source, like a light bulb, and they take scissors to the battery pack and cut it and show that, yeah, you get like a flicker on the light bulb for a second, but then it doesn't explode. The whole thing still keeps working, right? So there are a lot of really promising technologies out there. As with all things, batteries are a multi-dimensional crazy beast that you have to optimize specific energy, like how much energy you can cram in a given pound or volume, how much power you can pull out of it, how fast you can charge it, the costs, the safety, right? So all these things are playing into it. But I think that's from a vehicle perspective, that would be amazing to get a reasonable specific energy with the safety. I think that would be the big wish list for today.
I would just second that the amount of capital that has moved into the battery space from the automotive industry. It used to be that batteries, when I built or was working on my first electric VTOL in 25 years ago, we were running nickel metal hydride batteries, right? And you couldn't build a very useful electric VTOL with 40 watt hours per kilogram of specific energy. And this steady march of improvement in cells has been spectacular. We're now working with cells that are over 250 watt hours per kilogram and that have incredible safety. And so all of this capital coming from the automotive industry is just delivering spectacular gains in performance and in safety. And so now we have batteries today which we're building into our certified product. So we are there with the batteries. We have the battery we need, and that's because again, we're standing on the shoulders of giants here of 100 years of battery work, and it's this fusion of all of these technological pieces that people have built over over decades and centuries that make all of this possible, and that's what makes it magic to be an engineer and a technologist is when you can take all of these disparate pieces and find the patterns of a new emergent mode of transportation, and then the fundamental transformative impact that has on civilization, right? Our cities, our civilization is fundamentally built upon the automobile today, right? And the fabric of everything of our daily lives is all about the automobile. And if you change that, it allows us to reimagine everything, and it's just so exciting.
Next question.
So when I look at air traffic control, it's always pilot to system. But when I look at cars, other than looking at the green light, I'm looking at the group of people that I'm driving with. I'm seeing their taillights. There's somebody far ahead of me. I can see taillights. If I need to see a mile ahead, I can send a sensor package up, or I could talk to somebody up there. So what standards, or how do you see the evolution of the communication between devices in a potentially crowded airspace, collaborating and as well as trusting? How do you know that if they say it's a soft landing when you come in, is it going to be a hard landing? What's the story about that? A lot of issues.
Yeah, I mean, the vehicle-to-vehicle communications technologies that are available today are just spectacular, so they're and again, this is just standing on all the work that's been done in the semiconductor industry for car-to-car communications, and then you put it up in the air, and all of a sudden you find out that you have way more range because you're not being obstructed by buildings and that sort of thing. So our lives as innovators it's like kid in a candy shop. It's amazing to be able to take all of this incredible development and capitalize on it.
Speaking of disparate sources, right? I think for at least for Intel, we work on different technologies. So one of them is 5G. We're super excited about how do we get 5G into aviation. We have a drone group. How do we take the drone technologies, the collision avoidance, and how do we bring that to eVTOLs? And third is like the V2V and V2X and the V2I kind of things, right? Like how do we take all those technologies for autonomous vehicles and bring it to air vehicles? And I think it's a simpler problem than a lot of the ground transportation, but in many ways it's also challenging, right? Like how do you get the range and so on that you need for this? So technologies are promising. The building blocks are there. Everything needs to come together.
Nikhil, did you want to add something?
No, I think they covered it.
Great, thanks. Next question.
I have a question. Hi, I'm Shushman. I'm a PhD student from Stanford. But for this question, I want to wear not my grad student hat, but my annoying millennial hat. I think something that's very important to me and to a lot of people in my age group is, which the panel somewhat touched upon, but maybe not as much, is sustainability. And among the many axes that are important, I think the path to like breaking even or making an impact, if you will, in sustainability seems to me to be a bit steeper than some others, because you have all the resources that are going into testing and making these machines, and also all the auxiliary construction to actually enable them on a large scale. And then after all of that, you probably want to attract a significant minority of people who currently own cars, not the people in my age group who are more and more either biking or taking large mass public transit. You probably want to attract maybe the group that is actually currently driving on less fuel efficient cars. So it seems that only when you do all of that do you reach the path of breaking even on the sustainability aspect. I'm just curious what your thoughts are to that end, because to me, honestly, like after safety, which is the first point, that to me is the most important thing for a new technology like this. So some thoughts from the panel on that.
So I'll say that I'm a hardcore environmentalist, and it's one of the reasons that I thought, okay, if we can offer people something that's 5 times faster than their current mode of transport, it will be impossible. Even the person who loves driving a gas guzzler and is going to drive a gasoline car to their dying day is going to go, oh, you mean I can fly in that and I'll get there 5 times faster? And they'll be an instant convert, right? So that to me, this is, even though my core ethics are around wanting to move to a 100% clean solution, and I'm very dedicated to building efficient aircraft. Specifically to your question, we're moving people at 5 times faster, but with the same energy consumption as your electric vehicle, and so and which of course is a drastically lower energy consumption than a fuel-powered vehicle, and so I care immensely about sustainability. And the interesting thing is, if you're willing to reduce the speed, so instead of traveling at 200 miles an hour, you're willing to go 100 miles an hour, you can, the first human-carrying eVTOL that I designed was 100 miles. You could go 100 miles an hour on $1 of electricity. And so that was one person, 100 miles an hour on $1. And so that you can build a very, very efficient vehicle that is still much faster than driving, but is actually comparable in terms of energy consumption to riding a bicycle.
Next question.
Paul Smith with Black & Veatch. Happy to see this panel and familiar faces up there. So we build communications infrastructure, energy infrastructure, and I specialize in electrification. So working with NASA right now on a study nationally about this program. One of the other areas I wanted to talk about, first off, the real estate prices in Santa Cruz. Don't mess with those, because the buses are already kind of getting but otherwise, is the sustainability from an energy side, so everything we can do to pull it in renewably, but also business. So how are you tying this to freight and bringing the utilization of these vehicles and making the business model a little bit more sustainable, a little bit sooner, a little quieter on the ground? We've got a lot of cool examples. Want to hear about the air.
Yeah, I think this has huge applications for freight. And so we're thinking of freight in a couple of different ways. One is starting with the smaller vehicles and the movement of things. So we've got an $8 billion run rate Uber Eats business today that delivers food in cities, and it's growing faster than Uber ever grew at that point in its growth curve. And so this is a business that we looked at and we said, look, all the same benefits that apply to carrying people in aircraft, non-circuitous routing, traveling really fast, traveling all electric, traveling over cities, all of this applies to food as well. And so that's where we're starting. We're starting the IPP with smaller vehicles that can and will fly autonomously as soon as next year under Part 135. That will happen due to the FAA. So we'll start there. We've also got our Uber Freight business, and that is becoming an increasingly large part of our company as well, where freight is going through the same revolution that personal transportation went through a decade ago, around how do you make freight on the ground a lot more efficient? How do you make those vehicles higher utilization, higher load factors? And so I think what's next, and it's obvious, right, is all of these things will converge. And as we solve the passenger transportation problem, the small cargo problem, you can ultimately get to a solution that fits the big cargo problem. And this applies not only to cargo, it applies to emergency medical services, it applies to a number of things that require or could benefit from air travel, air transportation, and all of these technologies that we're working on.
Yeah. Vijay, how do you think about the market opportunity and what proportion perhaps is passengers?
Yeah, I think passengers is the first step, right? I think that the natural evolution is carrying goods, and we're already seeing startups which are trying to retrofit like a small, mid-size aircraft, fully autonomous, just to carry goods. I think we've seen companies where if you have a DHL or a FedEx flight, make it fully autonomous, maybe have a human or remote operator, but carry goods from point A to point B. So there's a lot of applications where it doesn't have to be like a short hop, but it can be a long hop, even a hybrid airplane, right? So there's a lot of applications for goods as well. And I think it's a combination of, hey, what makes the most economic sense?
Yeah, I think the last thing I'd add to that is if you have a vehicle, it's an autonomous aircraft, for example, that has 100 miles plus range, and you can carry anywhere from 500 pounds to 1,000 pounds, I think the sky's the limit. I think, yes, you can carry passengers, I can carry packages, imagine if there's an earthquake and I can deploy modular infrastructure, I can send paramedics, I can send stretchers, I can do all kinds of things, right? So I think like with any new technology, we here are just starting to see the surface as to what's possible, but the next generation, they're going to be the ones that say, oh my God, did you know if I had this one thing, I can do all these other things, right? And so I think really the sky's the limit with what you can do with these vehicles.
Next question.
Yeah, hi, my question is for Vijay. Vijay, I'm wanting to understand how you will do due diligence on something like this. So imagine that Joe Ben came to you like 10 years ago and he had this 10-year roadmap and he says, I'm looking to fund this company. What kind of due diligence would you do and what kind of milestones would you be looking for?
So we actually invested in Joby.
So what was the diligence like?
No, I think the big question for us back in the day, and I think like every year we looked at the space, the long pole items were always different, right? So at first it was, is the battery going to be sufficient to go to the space? And then second question is like, is the FAA ever going to allow this aircraft? Should we go look at aircraft in Europe, for example, where the standards could be slightly different, or maybe in Asia? So we finally came to a point where, look, it has to have a wing. It has to have multi-passenger. It has to be electric. So those are the baseline items, right? So then we went down on like which vehicle would be the right vehicle to do it. We talked to a lot of professors, a lot of universities. We spent a lot of time talking to Joe Ben. We spent a lot of time in the ecosystem, a lot of spreadsheets, just looking at the math. And I guess the open question is it going to be 2020, 2021, 2022? So it's more a timing question. It's not an if this will happen, right? And we have a lot of experience in autonomous vehicle, carrying goods and carrying passengers. And so that gives us a degree of confidence that this is more real than we thought it would be. And maybe just a last point to that one, right? A lot of this is not possible unless a lot of different players come together. As Jobin mentioned, we need to have expertise in carbon fiber. We need to have expertise in scale. So as we looked at investments in the sector, we thought, who would be the right players to come in and help develop this ecosystem, right? So automakers, service providers, with carriers and so on. So we try to bring everyone together as part of the investment.
Hi, Leslie Simone here. First, thank you for all of your efforts. I'm super excited about what you're up to. And there's one voice that I haven't heard yet about the health impacts. Like, are there doctors and other folks studying both the EMFs of all the electricity, if we're going to be introducing that so much more into our daily lives, and also even the speed if we're traveling at such pace way more frequently? I mean, granted, it's in shorter stints, but still. Are any physicians or any studies been run about those things, like the electromagnetic frequency or any of that stuff?
That was not part of our diligence. Love to hear if that's an issue.
I don't have a. Go ahead.
So I have flown millions of miles, and the biggest concern that I understand about flying is at high altitude, and you have less of the atmosphere protecting you. We're flying at lower altitudes, and so we still have all of the protection from the atmosphere. Your other question around the electromagnetics and the effects of those, I don't believe there's any concern there. The frequencies we're running at are to my understanding, not harmful. We all carry around cell phones, which I think the jury's out on whether they're harmful. So from my understanding, I don't believe there's a health risk. There's any adverse health risk associated with anything we're doing. But if you come up with any literature that suggests that electric motors. I mean, we've been using electric motors for a long, long time, and I don't know that there's been any evidence that suggests that electric motors are there is any health risk associated with those frequencies.
Look, I think to add that, for me, it's very simple. We started at, what, 5:30. Who here felt that their automobile commute here to the Marriott was beneficial to their health, right? Like, commutes are, and I think we talked about some of these studies in our white paper where it's the stress from commuting, particularly all of the stressors associated with that, running late and the maintenance around your car, all of these things in our lives. I hope we can eliminate all of those things. And so I hope, at least in that way, we can be beneficial to people's health.
Thanks. I'd also add, again, I don't know much about the electromagnetic effects. I do believe they are, as Joe Ben said, quite limited. But the fact is that even from a vehicle design perspective, we're trying to contain that noise ourselves. If I've worked on aircraft where if you don't do proper shielding, in other words, you don't contain that EMI, the electromagnetic interference, then your radios don't work, right? Early on, we did flight testing in a previous company and the EMI was so bad that we had to use like flags to tell the pilot what to do because we couldn't talk over the radios. Now we've learned those lessons. Everything is very, very heavily shielded, and all these issues have gone away. So even from a vehicle design perspective, it's in our benefit to shield everything.
Thanks. Next question.
Hi, I'm Haley from Intel, and I have a question, but I'm going to pass a few comments before I say that question. Firstly, great panel, great moderation. I'm super excited about this, and the reason I am is a few reasons, which we've already mentioned. A couple of things. One, I've lived through the adoption of the mobile phone, the internet, SqueezyJet. I've lived in Europe and been through that adoption of mass air travel, which we've already gone over that curve, and aircraft safety, which you pointed out, which is obvious. And now actually, I believe motor accidents are worse because of texting now, so there's that too. My final point on why I'm so bullish is because honestly, people are sheep, okay? People are sheep. And I moved to San Francisco when Uber started, and the fact that my father uses Uber tells me that people are sheep, and there's the adoption curve, and there's tipping point, and what I'm saying is that I don't care anyone in this room, and I've had someone text me tonight and say, oh, it's not going to happen. Bullshit. I think it's going to happen faster than level 5, and I've worked with autonomous driving group at Intel, so I can tell you that. And the reason is, I think, but this relates to my question. My question's about routing, because the only thing I can think, I live in San Francisco, and apparently the reason my AT&T doesn't work is because no one wanted base stations built there. That's what I was told, why I don't have good reception, on California and Franklin. So to that point, I'm really curious to learn about how Uber is thinking about routing, because I'm visualizing, routing over the water, and I'm also visualizing even like companies coming up with amazing parachuting systems, and there's going to be no problem with safety. I know that for a fact. So once I can get to San Jose in 20 minutes for $30, trust me, everyone's going to start doing it. When people are doing it and seeing other people around, that's exactly what happened with Uber. So I'm not even worried about adoption and demand. But routing and the people saying, oh, I don't want this flying over my house, what are you guys thinking about that? Because I feel like that, to me, is maybe one of the biggest barriers, and I know this because I've lived in Sydney where we have big airport noise issues, and I know it's a different noise issue, but I kind of see the same.
Thanks. So should we take the question? Thanks.
So look, first of all, thank you. Second of all, we're pretty much neighbors, so I think we're aligned incentives. But no, third, look, routing is very important to us. And we've announced cities of Los Angeles and Dallas where we'll be launching the service. We're also looking internationally. I was just in Sydney last week, and so heard much about those noise issues, et cetera. It's a really complicated problem, to be honest with you, but there's a lot of good things going for it. The first is, as I mentioned earlier, you don't have to solve the entire thing at once. You solve it piece by piece. You solve it with a single route first, and then you slowly grow that network over time as the public adopts it, as communities accept it, as regulators see that it's safe and it's acceptable. And then second is there's a ton of data here to help guide our decisions. And so the approach we've taken, for example, in Los Angeles, actually in Dallas as well, is we've taken our data. So we've got a ton of data over the last decade around how people move in and around cities. We've combined that with a lot of third-party sources of data because we're not moving everyone. So we now have a holistic picture of how people are moving around their city. And you can take that and you can do a lot of computer work around that and say, where can we make the most impact? Where are people today traveling to and from? And if you were to put a skyport here and a skyport here and a skyport here and have a computer run all of the different permutations and simulations, you can say with a high degree of certainty, theoretically, from a mathematical perspective, here's where what the optimal network looks like. Fortunately, the world is a lot more than just theory and mathematics, and you've got to apply the real-world layer to it. And so we've got a host of other variables and factors we're considering. We can talk about some of them and not about others, but we are solving this problem not in a single city way or a set of city ways, but in a global way. And so what we do is we apply all of these factors, and essentially you take that kind of base case that you came out with from your algorithm, and then you modify it based on all these real-world criteria, whether it's noise, whether it's thinking about flying over water instead of over land, whether it's thinking about, well, can you move the skyport over 2 blocks? You lose a tad bit of efficiency, but now you've put it right over a freeway. And so now no one cares about the noise because the noise just blends in with the road traffic. And the other piece of that is noise is a funny thing where people complain more where the noise doesn't benefit them. You see a lot fewer noise complaints about the Caltrain station at 4th and King, because most people who live at 4th and King live there for the Caltrain, versus people who live on West 30th Street in Manhattan complaining about the heliport that they'll never be able to afford a helicopter ride from. And so I think all of the things we've spoken about earlier today around how do you make this affordable and accessible and a key part of transportation in cities then goes into people saying, hey, this is not a nuisance, but this is actually a benefit of me living in this building. Every time they hear a small noise from an eVTOL, they're like, well, that's actually why I chose to live here. In fact, I paid more to hear that noise every single day because I can just take the elevator, go to the top of my building, and go fly to work. And so that's at least my vision. That's our vision. That's what we're working towards.
Thanks. Next question.
Hi, my name's Alec with Proudfoot Design. I just had a question about safety. What happens when the motors quit? Say again? Let me ask the question for the panelists, please.
Look.
I wasn't done with the question. I mean, if you have a helicopter with and the engine quits, you've got a skilled pilot, you should be able to do a successful auto rotation. We're talking about first having these manned and eventually being unmanned. most of the versions of these I've seen have vertical, I don't know if you call them rotors or propellers for the VTOL, and then they have wings for efficiency and they fly forward. Are you all counting on redundant systems? What are the solutions here? And I'm interested to hear from the FAA person what you're going to require for that issue.
So we are going with performance-based, risk-based sort of standards. And so we are not going to tell industry how to do it. We're just going to say, we don't want you to do X or Y, right? And so right now, under our current regulations, we have safety objectives in those regulations. And we would apply those safety objectives to industry, and we will ask them to comply with however they can comply with those safety objectives.
Yeah, I can give you like just architecturally examples of how we pull this off. So motors can fail. It actually is possible. I've seen it happen myself. They're far more robust than like an internal combustion engine where you have like high wear and tear parts. But it is possible they fail. Magnets sometimes come off, right? There's lots of things that can happen. In fact, as you said, there's propellers, right? So there's bird strike issues, all kinds of other issues that can come up besides the motor itself. Take that all the way back to the batteries. You have to manage that as well. What happens to the battery failing? We talked a little bit previously about managing the kind of thermal effects of that. But there's also just, that's your energy source, and what happens when energy source quits. So architecturally, let's start off with the battery pack. You don't have one energy source. You split it up into at least 4 pieces, right? So if you lose 1/4 of your pack, one battery pack rather, you only lose 1/4 of your system. And you have independent power distribution buses, so you don't have just 2 wires going to each motor, right? You have independent ways of getting power to each motor. So those wires could even fail, and that's still fine. Motors, it's kind of the same. Motors and propellers is kind of the same deal. We have some vehicles have 6, others have 8. I think Volocopter where they have 16, right? These vehicles are designed to have 1, 2, 3 failures before there's a significant issue. So it really does come down to architecture. We are targeting to hit these 10 to the minus X targets to be as safe as we possibly can be. And it's fundamentally, it's an architectural discussion. I'm sure Joe Ben can speak to that as well.
Yeah, I think you did a spectacular job, but that's exactly right. I mean, the thing that has driven one of the things that's driven these spectacular gains in safety over the last 100 years is the introduction of redundant systems. And whether that's on the flight computers or that's on we're able to put it into the propulsion systems. The beautiful thing about electric is that you can, electric motors scale much better than combustion engines and turbine engines do, where you really have a huge efficiency hit on a combustion or turbine engine as you scale it down. But with electric motors, you can add 6 or 8 or 20 of them onto an aircraft and still get good efficiency out of them. And then that allows you to put in the redundancy that will make these aircraft tolerant of any failure and allow them to continue to operate nominally.
I think one more point of failure is also the chips, right? So I think the compute itself, if that doesn't work, then a lot of times that's a failure there as well. So we work with certification. We've been working with defense and aerospace and for avionics and military for a long time. And I think a lot of those capabilities will come into the aviation space as well. So it's not starting from scratch. It's taking what's been happening over the last 50 to 100 years and bringing that into the aviation system.
That's actually, I mean, those strategies are already implemented in every single commercial jet out there today. For example, if you have the flight computers aboard the aircraft, it's not one that controls the aircraft. It's usually 3, 4, or more. And in many cases, a lot of times companies, to get those extra levels of safety, will have 2 separate teams design 2 separate versions of those computers, just so software and hardware in one does not result in the same kind of failures in the other. Right? So there's all kinds of games you can play with making sure that you have no single points of failure. In fact, the FAA has a requirement that you can't have single points of failure on your aircraft. Right? So this is it's fundamental to aircraft design.
Thank you. Next question.
Just really fast, I know we're running short on time, but could you just give a brief overview of what we're seeing in other markets? How is this developing in China? How's it developing in Japan? Are we going to see it here first? Are we going to see it there first? Is it developing differently? How are you seeing that?
Yeah. I think we've seen uptake all over the world. And so the FAA, I think, has been a pioneer here, where we've been working with the FAA for a long time, and a lot of other folks have probably been working with them for longer. And the FAA has been a leader, not only on the vehicle cert, on the operations, on the autonomy side of things, et cetera. But one of the things that I've gotten a lot of exposure to over the last year is people all around the world, and people are people, right? People are excited about that same exact value proposition in their city. And we all grew up dreaming about this. People grew up watching Blade Runner or The Jetsons. Who hasn't been sitting in traffic and said, yeah, how amazing would it be if the wheels could just fold up and we fly away? Like, all of us up here are contributing to that ecosystem in some form or fashion. And so when we go to Japan, when you go to India, you go to Mexico, or just in Australia last week, the response is universally exactly the same, which is, we want this, what will it take to get it? I haven't been to a single place in the world and been touting this message a lot of different places that have said, absolutely not, we hate this, it sounds terrible. Now, there are certainly people that are opposed to it, or people that don't think it will happen, or people that think it will be difficult, and that's fine and good. But regulators, and most importantly, the people that actually live in cities, live and work in cities, are universally excited.
If I could just say that certainly as far as the FAA is concerned, we would like this to be happening in the United States first and safely. And we're working with you guys.
And the good news is a lot of the world looks to the FAA for leadership and says, well, what is the FAA doing? What is the EASA doing? If they're cool with it, we're cool with it too.
Yeah, I think one more point is also about the cities, right? We had this person from Arizona talk about how they're open to getting the aircraft flying. I think certification is one we're seeing in Asia. As an investor, we look at companies across the globe, Europe and US and other parts. And I think the higher order bet is obviously regulation, right? And then second is we're seeing a lot of capital pouring in from other countries as well. So there's going to be like I would say not like an arms race, but at least there's going to be like a strong push from many countries to go and become the first or pioneer in this space.
Just one final point there. I think from a societal good standpoint, if you think about the impact that this can have in developing countries where there isn't ground infrastructure, it's even more of a paradigm shift and a transformative effect. It's like, places that didn't have, were able to afford to build telephone lines, but then they got the mobile phone, and it allowed, a total, massive impact in poverty and that sort of thing. Reduction in poverty because people could now do banking and things that, so this sort of thing where there's not ground infrastructure in countries that haven't been able to afford to build ground infrastructure will be very transformative there as well. So although it's, the economics will close first in the developed world, but the impacts are really profound for, and you see this with companies like Zipline that are doing blood delivery in Rwanda, and they have a spectacular business that they built around it. And so I think there's a lot of good that can be done.
Yep. One thing that's interesting is that this kind of cost of car ownership bogey is not an American-only statistic or figure. If you actually break down the cost of operating an air taxi, a lot of those costs scale with labor. And so you go to a place like India, it's no longer 46 cents a mile. It's, I think it was 43 rupees a kilometer, which translates to roughly 25 to 30 cents a mile. That's because roughly about half of that OPEX of operating an air taxi is labor-based. And so you think about, well, you can do maintenance locally. Fine, that's easy. You can build infrastructure locally. But then over time, you can even do similar to what Boeing does. It builds fighter jets in India with Mahindra, which is a large automaker. So even the CapEx, even the vehicle CapEx, again, scales with essentially the wage index. And so the conclusion we've come to is anywhere you do it in the world, as long as you have a sufficient market, sufficient level of kind of developed economy, then that kind of flying for the price of UberX, ultimately flying for the price of owning and operating your own car, it scales all over the world.
Yeah, I think the other two observations to make is that while there has been a lot of development of these vehicles, especially in California, there's at least half a dozen eVTOL companies, some more open than others. Europe has tons of them as well. Europe just released their new CS VTOL spec, so basically their certification for vertical takeoff aircraft. The FAA has CS-23, or Part 23 rather, which they've completely rewritten about a year and a half ago, I guess, at this point, to unlock these vehicles' certification potential, to make that whole process much more smooth. And then also, I think one interesting thing to note is if you look where a lot of money is coming from into this space, a ton of it is coming from China. So companies like Terrafugia were just acquired by some Chinese investors, right? So and even I believe Lilium as well. Like, so you're seeing a lot more investment coming in the space from China. So,
and not to beat a dead horse, right? So I grew up in a place called Bangalore. If 101 is bad, just imagine places like that, right? And the second is there's been precedent of a lot of the emerging economies skipping one or two trends. Like, for example, connectivity, they just leapfrog. And I think this is one of those things where if the infrastructure is not good enough, you probably leapfrog into the next mode of transportation.
All right. Thank you so much for sharing your insights and excitement and perspectives with us tonight. Thank you for being such an engaged audience. We really wish you all the best. As a very small token of our appreciation, we have for you, of course, the Churchill Club speaker T-shirt.
Woohoo!
That's what we can.
Thank you.
Awesome.
Thank you.
Thank you.
A recording of this program will be available on the Churchill Club YouTube channel shortly. We hope that you will share it with others who weren't able to be in the room that you believe would be interested. And you'll find recordings of most of our other programs as well, so we hope that you find that to be a very useful resource. Hope you'll also consider possibly joining us for our next program, which is a cybersecurity themed program in the same location on the 28th of this month. One more thing, if you did not get a parking sticker, there is one for you that will give you a discount if you're parked in the lot at Powell. And you've been a terrific audience. Thank you so much. Good night, and hope to see you soon.